So this is example 2. It would be example 2 on 3.4 notes. So you guys ready? Okay, so yesterday when we did this example, I said it's when you have 3 variables, you need to pick, I call it an anchor equation. That equation, you have to use one equation for both, and you have to decide which variable you're going to eliminate. So it's very important that you pick, I don't want to say an easy variable, but that's it. Like what is the easiest variable to eliminate? So if you look at your x's, I always pick my anchor equation is always the one that has a coefficient of 1. If you have a coefficient of 1, that's the anchor equation. So like x has a coefficient of -1, that's perfect because then I only will have to change one equation instead of many. Like I wouldn't want to pick the y's because I would have to change all of them. I would have to change all of the z's. So my anchor equation today is going to be this one. So that's the one that I'm going to write twice. So I'm going to write it -x plus 5y plus 4z, and then I'm going to write it again. -x plus 5y plus 4z, and it's really important that you actually write what it's equal to. So that's my anchor equation. Now I'm going to write the other 2 equations underneath it. So I'm going to write the first one underneath here. Make sure that you've written it correctly because there's you don't want to do one of these problems and you've made the first mistake was writing it incorrectly. So 4x minus 3y plus 6z equals 18. Then I'm going to write my other equation underneath. So we're going to stop and just make sure. At this point, are there any questions about why I picked this equation and how I wrote it?
Yeah, why did you pick the middle one again?
Because the x has a coefficient of -1. And I always like to have one of the variables to have a coefficient of 1 because it's easier to eliminate that variable. So we're going to eliminate the x's because that is the easier variable to eliminate. Does it always work out that way? No, of course not, but today it's going to. Okay, so now we're going to concentrate just on the x's. We don't care about the y's and z's. All we're going to do is we're going to focus on the x's. So what can I do to this x so that the 4's the x's eliminate? That's what I should say. So what should I multiply -x by so that it eliminates the 4x? 4. Now remember, I'm going to multiply everything by 4 then. It's just not just the one thing. I'm going to write everything. So 4 times -x is -4x. 4 times 5 is 20y. 4 times 4 is 16. And then 4 times 48 is some number. It's 192. See, I figured it out. And then the 4x will stay the same underneath. So again, we multiplied the top equation by 4 because that's how the x's would eliminate. Now, would we add the 2 equations or subtract the 2? Add them because they're opposite signs. -4x plus 4x is 0. 20 plus -3y is 17y. 16 plus 6, what is it? 22z. And then 192 plus 18 is 210. Let's make sure, because if I make a mistake,
Wait, oh, that's 18, not
Yeah.
20.
Okay, so we're good on this one, right? So now we're gonna come back over to this. So we eliminated the x's, so now we have an equation with y and z. Now we're gonna come over here and we're gonna eliminate the x's again. You can't pick, oh, I'm gonna eliminate the x's on this one and the z's on this one. You have to eliminate, if you eliminate the x's in this equation, you have to eliminate the x's on this equation. So what can I multiply the x by, the top equation by, so that the x's eliminate? 6, because this one is 6, so we're going to multiply the top equation by 6. So 6 times negative x is negative 6x. 6 times 5 is 30y. 6 times 4 is 24z. And then 6 times 48 is 288. And the bottom equation stays the same. So just so that we remember again, you have to eliminate the same variable on both. You have an anchor equation and then you eliminate the same variable. You can't eliminate different variables. Okay, so am I going to add or subtract? Add, because the 6's are opposites. If they were the same sign, you guys, you would subtract. But because one is negative and one is positive, we're going to add. Negative 6x plus 6x is 0. 30 plus negative 2, 28y. And then 24 plus 5, 29z. And 288 plus 0 is 288. Now we have two equations, right? That we can now eliminate those. So now we're going to rewrite them. Yes, this is going to take a while and takes up a page. Didn't I say that at the beginning of the year? You probably didn't want to listen to me at the beginning of the year, did you?
I don't remember that.
Now, nothing's the same, right? These are awful numbers. And what I mean by awful numbers is they're big. And can you make a 17 into a 28? There's nothing you can multiply 17 by to get 28. Is there anything you can multiply 22 by to get 29? Okay, so, and we can start trying to figure it out, and the numbers are just gonna be big. So now what we have to decide is which variable do we want to eliminate? Do we want to eliminate the y's or the z's? And it doesn't matter, you guys, it really doesn't matter. We just need to pick one to eliminate. Okay, so if we're going to eliminate the y's, okay, so we've chosen the y's, this is what I do. I don't, like a lot of teachers say, hey, let's find a number that they go into. I just say, let's multiply the top equation by 28, because that's the coefficient of the y on the bottom equation. And then what am I going to multiply? What do you think I'm going to multiply the bottom equation by?
17.
Yes. JD, can you pull your mask up over your nose? Thanks. Okay. Now what am I going to do? Multiply. These numbers are not going to be pretty. I mean they are pretty. It's just they're going to be really big. So now I have, let's see, 476y plus 616z equals 5,880. 17 times 28 is 476y plus 17 times 29 is 493z, and 17 times 288 is 4,896. So I basically just multiplied every number by 28, and I multiplied every number on the bottom by 17. Now, we're going to eliminate the y's because they're the same. Are we going to add the two equations or subtract the two equations? We're going to subtract because 476y, it has the same sign as the bottom one, so we're going to subtract. 476y minus 476y is 0. 616 minus 493 is 123z. 5,880 minus 4,896 is 984. Now what am I going to do? You guys, when you finish one of these problems, you feel very like it's amazing when you do this problem and it works. Yeah. Oh, trust me, I've gotten them wrong. Okay, so what is 984 divided by 123? It is 8. Okay. Now, we can't plug it back into one of the original equations because we only have one variable. So now what I need to do is I need to plug it into one of the equations we made. That's why it's really important, you guys, that you're paying attention to all the little details. So what I'm going to do is I'm going to plug it in. I'm just going to use this equation right here. So I'm going to take 17y plus 22, and instead of z, I'm going to put 8. I'm going to replace z with 8. And I'm going to put 210. Now what am I going to do? I'm going to subtract 176 from both sides. And then I'm going to, and y equals now we have our z, we have our y. What's the last variable we need? X. So now if we go back to our original equations, which one do you think we should plug it in for?
-1.
We should plug it into the one that we picked for our anchor equation because x is negative. That it's just there, we can divide by 1. So we're going to go back to that, and I'm going to write negative x plus 5 times 2, because it was 5y, plus 4 times 8, because that's what z is, equals 48. You guys, I know that you probably could have gone negative x plus 40, gone to 42. I just writing that just because I like to write all of my steps out. 48 minus 42 is 6. I'm going to divide by -1 because you can't leave a negative variable. And x equals -6. Now, can you make sure that you did this correctly? How can you make sure that you did it correctly? Plug all of these into the original equation. So my final answer is -6 to 8. That's my final answer. Oh, that's a set. Put it in parentheses. My final answer is this ordered pair. And remember, it always goes X, Y, Z.